In this video, we're going to go over an example of normal distribution. So for those of you who don't know what normal distribution is or how to find it in your calculator, I strongly recommend that you watch the first video that I did on normal distribution and then watch this one. So it says a manufacturer calculates that the lifetime of his laptop batteries is normally distributed with a mean life of 28 months and a standard deviation of 7.5 months. The manufacturer gives a 12-month guarantee on each battery. Part A, what is the probability that a battery will last at least 28 months? One of the things to note here is the fact that this is a normal distribution problem. Notice it specifies that the lifetime of the laptop batteries is normally distributed. So that tells me that I can describe this as a normal distribution. So X is normally distributed. The mean we know is 28 months. And the standard deviation is going to be 7.5 months. So if you were to be asked to write the distribution down, that's how you would write it. They're not asking me that, but I wanted to show you anyway. So then to answer part A, I'm going to just very quickly create a bell-shaped curve. In the center, I have the mean, which is 28. And the question says, what's the probability that the batteries are going to last at least 28 months? At least meaning greater than or equal to 28. So that means I'm going to shade everything that's to the right. Obviously, you should know this answer because the entire area under the curve is 1 or 100%, and the mean is right in the middle. So without even doing the calculation, we know this is 50%, or because the question asks for the probability, then the correct answer is going to be 0.5. If we look at part B, it says, what is the probability that a battery will last more than 38 months? So again, I'm going to create a bell-shaped curve. In this case, I'm still dealing with a mean of 28, but I want to find the probability that the battery is going to last more than 38 months. 38 is going to be somewhere on the right-hand side. I could be more accurate by figuring out the standard deviations and plotting them, but I'm just kind of doing a rough sketch. So here that means that I need to go to my calculator. I'm going to go to second vars. I'm going to go to option 2, which is normal CDF. I'm going to enter the lower bound, which in this case is going to be 38. My upper bound is positive infinity, so 1e99. The mean is 28, and the standard deviation we were told is 7.5. So let's go ahead and go to the calculator. So in the calculator, we go second vars, which is distribution, option 2, normal CDF, which is the cumulative density function. You press enter. The lower bound in this case is 38, and then the upper bound is positive infinity. So 1e, which is second comma, 99. The mean in this case is 28 with a standard deviation of 7.5 months. Press paste, press enter, and the answer is 0.0912. For part C, it says, what is the probability that a battery will last less than 12 months? So here we go once again. I create my normal curve. In the middle, I have the mean, which is 28. This time it says, find the probability the battery will last less than 12 months. So I'm going to head on over to 12, which is going to be somewhere there. And I'm going to shade to the left because I want the probability it's going to last less than 12 months. So that's what I'm looking for. So I'm going to go to the calculator once again, second vars, option 2, normal CDF. In this case, my lower bound is negative infinity, so negative 1e99. The upper bound is going to be 12. The mean is 28, and the standard deviation is 7.5. Second vars. Option 2, normal CDF, because it's cumulative. We want to get everything that's to the left. Here, the lower bound is going to be negative infinity, so negative 1, second e for exponential, 99. Go to the upper bound, which in this case is 12, because we want the probability that the battery is going to last 12 months or less. Then the mean, of course, is still 28. Standard deviation is still 7.5. Press enter for paste, enter again. And so we have a probability of 0.0164. So the probability the battery lifetime is going to last less than 12 months is approximately equal to 0.0164. For part D, it says the manufacturer makes 5,000 batteries each month. How many batteries can he expect will be returned under the terms of his guarantee? Well, if we go back to the problem, it says that they're giving a 12-month guarantee on each battery. So we have to make sure that this battery is going to last 12 months or more. In part C, we just found the probability that the battery is not going to make it to that 12 months, which is the guarantee. So in terms of how many are going to be returned, we're going to have to multiply 5,000 times the probability that that battery lifetime is not going to make it to 12 months. So this is going to be approximately 82 batteries if you multiply. Finally, it says the company accountant thinks the figure in D is too high. So returning 82 batteries out of 5,000 that are sold, and the accountant is thinking that number is too high, we're losing money, should the manufacturer aim to make the standard deviation larger or smaller? Remember, the standard deviation is the average distance of each value from the mean. It tells you how spread out the data is. The bigger the standard deviation, the more spread of your data. And the smaller your standard deviation, the less spread out your data is, so the closer it is to your average. So in this case, if you think about it, you should already be able to come up with the answer. One of the things that you need to realize is that if this were a test question, you need a way to be able to answer it. And so there's nothing wrong with going to your calculator and just playing around with different standard deviations to determine whether or not that number of batteries is going to become less or more. But in this case, it should make sense that you want the standard deviation to be smaller so that you are closer, in fact, to the average of 28 months. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.